Anyway, now let's get to the last part of 10.3, and let's work this out together. And also, we'll take a look at some questions from the review packet to address any potential issues with the graph. So one more time, right? We complete the square for variables, but you're only going to have to do that for variables that has, a quadratic term. So we're looking at y squared plus 2y. Right, so I need to figure out what add to these two terms to complete the square for the y. But I mean, obviously, you don't have to do anything about the x for now. So why don't you put the term 12x and the negative 30, negative 23 on the other side. And now let's figure out what constant you have to add it to, the two terms. So please understand, we do have a trivial case since there's a 1, right, as the leading coefficient. So what you'll be adding to the y squared and the 2y will be the square of half the b, right, or b over 2. So 2 over 2, and don't forget that once you add a number, just in case you forget, to balance it out, subtract off right away. Right? So that means now you still have the same equation, right? Even though it looks different, but it's the same as before. So now go ahead and factor the first three terms, right? So you're going to be dealing with the y, and the constant that you'll be adding or subtracting from the y is actually whatever that you're getting before the square. Okay, so you'd be adding the 2 over 2 is 1, right? So y plus 1 square. So then you have a 1 square, still 1, subtract from the square, right? That's still there. And that's negative 12x plus 23. Now, always keep in mind the standard form that you hope to get for the parabola. It looks very different from, 10.1 and 10.2. So let me put that in parentheses here. So we're hoping it will be y minus k, right? Square. In this case, since y gets the square. 4p x minus h. All right, so that's the form you're trying to get. And I see that we pretty much have the perfect square already, right? So let's just keep it that way and leave it on the left-hand side. And I don't need that negative 1 on the left-hand side, right? So adding the 1 to get this, to the right-hand side. So you'll be looking at negative 12x plus 24. And then we need to see what 4p is, right? And also, at the same time, you want to see what the h is. You could do that just by factoring the right-hand side, right? And I'm not saying it's guaranteed, but probably more often than you can think, they have the numbers work out like that. Right, so you just take out negative 12, and be mindful that the sign might change, right? So it'll be x minus 2. And please quickly check that if you do distribute a negative 12, right? And the second term will be negative 12 times negative 2. So it does return a positive 24. Okay. So now we need to find out the vertex, the focus, directrix. You don't have to graph it, but it's always a good idea to sketch it. So then, in case you have to match it with a graph in a test, I suggest that you actually sketch it right away. So then, when it comes to reading off the coordinates of the vertex, focus, and directrix, it'll be a bit easier for you to tell right away. All right, so let's see. But first off, is this a horizontal or a vertical opening parabola? you have the y getting squared, x. So if it's a vertical, would you say that it should look something like x squared? So it's going to be the other one, right? So I know it's 50-50, but that's why don't jump to the conclusion, because the reason why I'm asking you is you should ask yourself in a test, because you definitely have the time, at least in the third test, to ask yourself one more question. Is it right? Is it vertical or horizontal? Now, if it's a horizontal parabola, does it open to the right or left? Horizontal has to be to the right or left, right? So what do we look at? The sign of the P, right? So if it's a positive P, it opens to the right. But in this case, it's negative, right? So we'll say that it will be a horizontal parabola opens to the left. Now, where are the vertex? You can see that we have the K, right, and the H. So H, K are the numbers that you're subtracting from the X and the Y. So you're subtracting 2 from X, so H will be 2. But the K is not 1, but -1, right? This is subtracting from, the Y, right? Subtracting -1, you do get +1 right there. And the P is going to come from the constant there in front of the linear factor, either in terms of X or Y, but in this case it's in terms of X. 4P is -12, therefore, -12. Therefore, P is -3, right? So let's find out where the 2, -1 is. 2, -1, so it'll be something like this, right? That's the vertex. 2, -1, okay? -1. It opens to the left, right? Let's just draw something like this. And it doesn't have to be accurate when it comes to like how big it opens, but you definitely want to see a parabola that opens to the left. Again, it's not accurate when it comes to the size of the opening. Now, once you have a graph, a sketch, so we've got the vertex. The focus is always going to be lined up with the vertex. That has to be along this dashed line. But just think about why we call it focus. That means the graph will somehow focus on the side, right? Where the focus is. So it actually opens towards the focus. So in this case, if this is the vertex, the focus has to be to the left of it, since the parabola opens to the left. But as you probably recall, if you don't, that please remember that the way to get a focus is to start from the vertex, go either one or the other, right? Sometimes to the left or right or up and down, depends on which way it opens. In this case, it's to the left by the exact number of units, the same as the absolute value of the P. Or you could think of P is -3. That means you are going to the left, right, to find the focus. Therefore, in this case, the focus will be at the same vertical elevation as the vertex. So I should keep the same vertical coordinate, -1, right? But in order to go to the left by 3 units, I need to subtract the 3 from 2. So we're looking at -1, comma, -1. Right, so that's where the focus is. Now, directrix. It will be a line that is always perpendicular to the axis of symmetry, right? The line that I just draw passing through both the vertex and the focus, but it has to be on the opposite side of the vertex compared to the focus. That has to be somewhere here, right? Or let's go with dash the line. So I know that the line has to be vertical, so that has to be some kind of a x equals to a number, right? So the directrix will be x equals to something, right? But since now I need to go to the right by the same distance, right? So if you have go to the left by 3 units to get to the focus, go to the right by 3 units. Since the vertex, is located at 2, right? Therefore, I need to go from 2 to the right by 3 units. So you're looking at x equal to 5. Okay, so this vertex, this directrix will be x equal to 5. Okay, let me zoom out a little bit. All right, so I think that probably the completing square part should not be a problem anymore. But if it is, let me know or see me doing it office hour. So make sure that you are tracking the center or slash, the vertex for parabola correctly, because it does look a little bit different from, the ellipse and hyperbola. Not to mention, there's only one focus, and it depends on the P. And you find out the focus by starting from the vertex, going either one way or the other, depends on the value of P or the direction of the opening, right? And make sure that the focus and the vertex are always going to line up on the axis of symmetry. Then when it comes to directrix, it will be a line, could be vertical or horizontal, and again, whatever line it has to be, it must be perpendicular to the axis of symmetry. Okay, and it's going to be on the opposite side of the vertex. So just make sure that either sketch the parabola or at least remind yourself when going through the options, the correct location of focus in the directrix. Okay. So now, if you guys are okay with this kind of problem, well, at least see how that works out, and probably try something similar. Not right now, because I'm gonna show you some other techniques dealing with the parabola, just to be safe. If you like to do the routine things, by all means, give it a try. But I hope that maybe since this is going to be multiple choices tomorrow, eliminate as much as you can. Now, so I pulled those 4 questions from, and those are probably the only 4 questions in the packet for chapter 10 when it comes to parabola. Well, there are probably a few more, but they're pretty repetitive. I'm not too worried about 30 and 31, since the vertex are trivial, since that you don't have a shifted parabola. I think it's probably be easier for you to track the the focus and directrix. But why don't we look at question 35? Yeah, 35 together. So let's see if you have to do it as a multiple choice question. Is there a better way than work everything out? I mean, which you could. It's not going to take you too much time. But let's see if you could take a look at those things like vertex and focus to see if there's some option that you should have eliminated in the first place. All right, I'll let you try it. Maybe going through the option for a minute or two, and tell me you could just screen through the options and still figure it out. All right, so go ahead and give it a try in 35. Just in case, I'm going to remind you the standard form in this case, x plus h, actually minus h, right? Minus h square equals 4p y minus k. I guess that the first thing you should be looking at, well, since you're going to go through options anyway, right? So where's the vertex? 1, -1, comma, -4, right? That means you should eliminate A and a D, right? So, I mean, the vertex seems fine, right? B and C. Okay, so now you see that the focus is are different, right? Now, is this a horizontal or vertical parabola? Vertical. Opening in what direction? It is negative. So negative, well, the direction that we find more intuitive, if you have a positive P, will be either to the right or up, right? So those are the intuitive directions. But if you have a negative P, that means it's going to go either left or down. It depends on whether it's horizontal or vertical. But it's a vertical parabola, that means it opens down, right? Now, if the parabola opens down, on which side of the vertex should you expect the focus to be located? Opens down. So it'll be somewhere underneath the vertex, right? So now the vertex is going to be a -1, comma, -4. Should the focus be here? -1, -6, or should the focus be -1, -2? And that's the one that has the correct location, relative speaking, right? So let's go with the C, since there's something wrong with the focus, right? I mean, should you do the same thing like we did, at the end of the packet, 3.5, figure out the P, right? Find out exactly what the focus is in the directrix. You could, right? And some people like the directrix. They say, look, if the vertex is somewhere at -4, it opens down. That means the directrix is going to be on the opposite side of the vertex. So it should be -2, right? Which is going to be higher than -4. Instead of -6, right, which goes further down. Either way, right? I guess that narrow down to 2 options, right? And you're not even guessing 50-50. You're trying to eliminate one of the options that just looks absurd when it comes to the relative location of the focus or the directrix. Then you should be confident enough to be picking whatever that's left. All right. Now. There are 2 more questions, which I don't feel like going through, since you see that you just do the same thing. Instead of stating these graphical elements like directrix and focus, you'll try to read off their location. I know it's kind of hard since the graph will be kind of hard to read, right? But there will be not many, but a few questions are like that in the test. So I'll say that try to look a bit closer. But you always have to look to the options and find out something that you could have used, right, to eliminate them. For example, can we read off the vertex right away in 36? It will be -2, comma, -1, right? So this should be in the 3rd quadrant. Therefore, you should be looking at either, unfortunately, B, C, D, right? But you see that the 2 options, B and C, right, states that the parabola has to open to the left. D says open to the right. but you know, just like SAT, right? So if you have multiple options that has something similar to each other, so you might find, you know, a better chance to find, you know, the answer between the B and C, right? But can't you convince yourself the parabola in this case is indeed open to the left, right? Do you see that? It's a horizontal parabola with a negative p, so it does open to the left, right? So now if you're down to a B and a C, do you see any difference between these two? I mean, unfortunately, they have the same exact vertex, right? The same exact direction of opening, right? But I think you can see that letter B opens a lot wider. That means if you want, if you remember something called the latus rectum, right, you can try that. But if you don't remember what it is, take a look at some, you know, special points on the graph. So I happen to notice a point right there, right, which has a vertical coordinate to be 5 and a horizontal coordinate. So this is -5. All right, so let me zoom in a little bit more. All right, so would you say that this point looks like -4, comma 5? And I'm sure that, you know, the graph in letter C doesn't have that. Why don't you evaluate that point back in the equation to see if that works, right? Just to get yourself more confidence picking it, right? But in this case, I think that the answer for 36, yeah, 36 will be letter C. That means, you know, you take that point, plug it in, it won't work. But again, you know, x is -4, y is 5, right? So sometimes, you know, you have the x on the left and right. Just be careful with it. Okay. Yeah. So unfortunately, you know, it's the same thing, but you just have to deal with, you know, those ugly graphs. Right. So figure it out. You know, maybe some safer way to do it. Anyway, now. And once again, you know, if you had, you know, some little mistakes and you don't even know what happened in a quiz, that means either, I mean, could be the trouble with the graph, right? But somehow, you know, if there's certain things that you didn't realize what happened, better talk to me either later today or tomorrow, hopefully before the test, so we can look into maybe those issues. Okay. Anyway, so let me focus on the oh, you know, it's about the time. So why don't you take a break and come back in 10 minutes? Then I'll take a look at the chapter 4 review packet. I'll make sure that you guys get to download the critical part for chapter 4 for the purpose of tomorrow's test. Hey, you made it. I mean, yeah, well, it's okay, you know, just find me during office hour, you know, whenever you can, because I just have to, you know, maybe sit there and get the quiz done, then I might just talk to some of the students. Okay. Yeah, so just yeah, I'll be well after 9:20. Okay. Yeah.
It's just the thing in the 12.
Yeah.
I'll share the paper too.
Okay. Okay. Okay.
I'm pretty sure that's what said.
Oh, Samantha, are you taking a final on the 18th?
Yes.
You're not on the list, so you might have to reach out to Miss Hagood again. And
But I was the first to get in contact with her. So
well, you know what? She's been sending out for many different versions. I think that they're getting all the names together, so it might be an error, right? If you have her approval, then yeah. So tell her that you need to be on the list because all I see is Jakari, right? So you'd be taking the final on the 18th. Rosalind?
Oh, she already sent the list. Well, no.
Oh, I guess this is a misspelling.
they spelled
Rosalind?
your name wrong.
That's you, right?
They spelled your name wrong.
Yeah.
Oh, okay. So, all right. But I mean, if I know that you'd be taking the final, that's fine. On the 18th, you'd be taking the final on the 18th. Yeah.
They don't.
I'll talk about it. But you two on the list. Samantha needs to still reach out and make sure that they're. Let's see. Wait. What's the last name? Am I right? Do you see that? So you don't see her name. That's it. That's the last version. It was like only a couple minutes ago. All right. Anyway, it should work out. Like I said, they're just trying to put all the names on the list, and this is the third version I've got this morning. Yeah. They keep adding students. So but you're fine. So now, guys, I know that we only have probably 2 or 3 students in this class taking a final on the 18th. But if you have your friends, at a different class that have to take the final on the 18th, let them know, or please remind them. For Central Campus, it will be the 18th at 9 a.m. in Building 3, room 100. I'll put it on the board. All right, so Central on 18th at 9 a.m. Building 3, room 100. If you happen to have any friends at North, again, the same day, 18th. The same time, the room will be CA conference room. All right. As for the early final, for math. All right, so now let me double check. I have Jakari, Rosling, and potentially Samantha, right, taking the final on the 18th. Nobody else, because that's all I see on the list. Okay, sure. All right, so let's get to chapter 4. So the packet. Well, no, you can take this one. Yeah. But I'll give it to that in a second. No, you can take it. I'm just, I have to refer to it, in a second. Yeah, I'll give it to you like in a minute. All right. Now, the packet I give you guys, I think maybe last Thursday, right? So the chapter 4, it has 4.1 all the way to 4.4. So those are the things that we'll be checking on the test and the final. But let's just be realistic, right? So tomorrow the test is mainly just about chapter 10. But there will be, if I remember correctly, 4 questions about chapter 4. So 4 out of 20 questions, all right, multiple choices, no FRQ, all right? So 4 out of 20 about the chapter 4. And at least right now, if you just reviewing for the test tomorrow, you don't have to worry about 4.4, which is about solving equations. All right, so it'll be 4.1 to 4.3. As you can see that most people should be fine with 4.1. It's just very basic, exponential functions and graphs. Don't forget that you could graph, in a TID4, right? So there's not much, that will bother you, unless you forgot about those basic properties, exponential stuff, right? How to, combine expressions with the same base, but raise to different powers, stuff like that. Anyway, so now the math you have to deal with in a test, tomorrow will be most likely about the logs, right? So 4.2, 4.3. As you can see that on the top of page 2, you have those 4, actually 5, right? Properties. Sometimes you get log that evaluates and get you 1, or splitting, right? Or merging the logs with the product rule, the quotient rule, right? The power rule and the change of base property. So those are the things that pretty much you're gonna have to deal with for most of the algebra on the test. But now, again, you're looking at graphs, okay? And I'll talk about the graph in a second. But I'll say that the reason why I said that you have to focus on those properties on page 2 and be mindful that there might be some algebra you have to do. You can find more reference for the level or the type of the questions from page 4 in that packet. I do type up some examples for you to remind yourself how you did that back in college algebra. But I'll go over some questions from the test 4, chapter 4 review packet to get you more exposure on these things. Okay. So again, just to wrap up, you should know the basics of 4.1, but it's not going to be a whole lot, and I think that it shouldn't really bother most people. It's pretty much all about the property of the logs and using it to either expand or condense those log expressions, okay? And there'll be something about graphs, since there's only 4 questions, it might be just 1 question about graph, but please make sure that you use the calculator to assist you when it comes to the graphing, okay? Anyway, now I'm talking about the packet that I posted probably most recently, right, about chapter 4. I didn't put in, the question numbers corresponding to certain topics, but I'm going to let you know certain math techniques or skills you have to be able to, show me on the test. For example, from the first couple questions, starting from number 5 to number 10, it's all about graphs. So let's say if you're dealing with question number 5. So at this moment, what do you think you will do for something like question number 5? What is that, you should try going through the options and maybe make a guess, right? This is still 25% chance to get it right. So how many of you know how to graph in the TID4? All right. So, and also, how long will it take you to type up a function like this and graph it in TID4? 10, 15, 20 seconds, right? Or let's say 30 seconds. So yeah, I think so, yeah. So now, of course, if you see it, if you do remember back in college algebra, then by all means, right? And maybe in a second, Zach, could you share with us, how you did that? But if somehow you feel like that, there's only that much you can do before tomorrow, try to type up, for example, so I don't mind to show you right away in TID4, so we're on the same page, how to use the calculator more efficiently. So let's say if I type up letter A, so I go to the y equal kind of thing, right? I clear it up, right? So let me type up log 5. You guys know how to type up the base for a certain log in TID4? So you can either use the change the base property, but it turns out that you could go into math right there. Unfortunately, it doesn't show up on the first page. Scroll down. It's called log base. All right, so highlight that, hit enter. So it's going to ask you what base you want. Right? Go ahead and put in base 5. Then in the parentheses, you're going to type up the argument. But please make sure that you know there's a difference between here, x plus 2, in the parentheses. That means both x and 2 is going to go into the parentheses there. But here, you don't see the parentheses, right? That means it's only the x that stays inside the log. All right, so you're going to put in x. All right, just hit that button. And go outside of the parentheses, and you're going to subtract 2. All right, and hit enter to save it. And then go ahead and graph. But of course, if you don't see the entire graph, right, just to be safe, hit zoom. And what I like to do is always go to the option where it says zoom fit, right? So I can see the whole picture, right? So let's hit it. Now, do you see that? It does not match the graph they provide you. See that? It's getting super close to the y-axis, but obviously that's not the case. Right? It's gonna go something like this. So I hope it won't take me that take you that long, since I have to talk to you, show you all the steps, right? So know what to do to put in the base you want, type up a function, and quickly plot it and use it to find out where which option to pick. But this is bad because you have to go through those options, right? Type up the equations, right? But what if I have the equation right there? Let's say I said that, well, go find which of the following graph that matches the function like this. You're going to just type up once, have the graph, and compare with all the graphs and see which one that matches. And that's the point of having the graphing calculator. Does it make sense? Now, Zach, would you mind tell us what you do to figure it out that D is the right option? Okay, so Zach's looking at the domain, right? So you realize that whatever that stays inside the log has to be positive, not even 0. That means x has to be greater than 2, right? And it seems that this is the only one that does agree with the graph, right? Because the graph is saying that everything to the right of the 2, right? So that's looking at the domain. So if it works out for him, that's fine. Well, you know what? Like I always tell my students back in the college algebra, why don't you take a look at the x-intercept or y-intercept if this is 1? Can you read off that point? It's 3, 0, right? That means if you were to evaluate every single function by setting x to be 3, it should return 0, right? Now you can do it algebraically. You can define a function, right, and recall the function, evaluate in the calculator, or just simply type up log 5, 0, right, minus 2, but make sure that you're subtracting 2 from the entire thing. And I'm sure that you're going to come all the way here and realize if x were to be 3, 3 minus 2 is 1. What is log 5, 1? 0. And that's one of the property on page number 2, right? There you go, right? So either way, you should do that, instead of getting freaked out because, it's a log function, right? It's a graph. You can either have the calculator to work it out for you, you can either find out those special points, plug it in, and see which option that matters, right? That matches. Or if you're looking at just like Zach did, the domain and whatever, or let's say, how many of you like to do the transformation, thinking about, in this case, it's a vertical shift downwards, right? That's a horizontal shift to the left, to the right, actually. But the thing is, you have to know the parent function, right? So what does the log 5x look like? Well, you can plot it, right? But I mean, why bother if you could have just plot the whole thing? Now, why don't you guys try one, just to see how it works out. Or I think that wait a second. Now, guys, go ahead and type up. I hope it's not too small. So I'll write it down. So they want you to graph, pretending you're graphing it, right? G of x, which is -4 ln, which is the natural log of x. And I'll zoom in a little bit. So, but you don't have to type up and graph it. If you already tell which option is right, that's fine. But if you want to try the graphing calculator, do it now and tell me which one you get. All right. So number 10, just go ahead and figure out which graph that matches -4 times ln x. Okay, however you want to do it. So number 10. You guys get it either from a calculator or you looked at the options, then you see someone that just makes sense. And it turns out so let me see, number 10, right? Number 10 is A. All right, so now of course, you can always try to see those x-intercepts, right? They're easy enough to read off. So this guy has x-intercept at 1. This is 5. That's 1 as well. That's 0. You know what? I think that one of my students in the spring semester told me if there are a graph that has something repeating, that might be very likely the correct options, right? So I guess that in this case, well, it seems trivial if we already figured out what the answer is and just try to, say something to convince, other people, right? But it turns out that that's what those people do to, create distracting items, right? Anyway, but I'll say that at least that you should feel confident with plotting it in a TI-84, in case, you always find the graph kind of hard to track. Anyway, so now moving on to, I'm glad that Zach mentioned something about domain. And I do believe that back in the fall, people might have some, little issues with identifying the domain. So what you need to understand when it comes to questions asking for domain of log functions is that whatever the stuff you put into the log function, right? Let's say log of b of, let's say g of x, could be a complicated expression of x. To make this function define, you have to make sure the stuff inside the log must be positive. Okay. That's not negotiable, right? So not even negative or 0, right? It has to be positive. So now let me highlight the part that stays inside the log from those questions. And let's see some of the easy ones that I hope that you can read off right away from the options. Okay. So basically, first guy, x minus 6 has to be positive. Don't you think that x has to be greater than 6? Well, the way you see it, if you want, write down one more step. X minus 6 must be positive, right? You guys still remember how to solve the linear inequality? X squared than 6. Now, that's just a fancy way to say, right, from 6 to positive infinity, right, anything that to the right of 6 or greater than 6. But what about 14? You guys try it real quick? Okay, some say C. Hikari, right? How did you figure it out? It is. Okay, so you look at the denominator. So I want the whole fraction to be positive, but the numerator is already positive. So I have to make sure that the denominator is also positive. That's saying that x minus 4 must be positive, and therefore x has to be greater than 4. Right? There you go. All right, now what about number 12? All right, so try number 12. Okay, so Zach says it's B. Can you tell us how you figured it out? Good. So Zach noticed that this guy, since it's getting squared, it's always non-negative, right? It could be positive, could be 0. But you have to rule out 0 for this whole thing, right? But do you see that letter B is an option that just skip that number 7, because that's the only number that could turn x minus 7 squared into a 0. Okay. Yeah, that's the way you see it. Or if you insist, let me write this down: x minus 7 squared, right, greater than 0. Do you guys know how to solve a polynomial inequality, or in this case, it's just a quadratic inequality? Do you still remember that? It's very similar to solving an equation, but inequality gets a little bit tricky since you have to account for infinite many solutions. Now, in number 12, if you decide to seriously solve for an inequality to convince yourself that letter B works out, so we're looking at a polynomial function. I don't know if you realize it's in a form that's so special, x minus 7 square, right? And I want it to be positive. What do you think the graph of this function look like? It's a quadratic function. It has to be a vertical parabola, right? Either opening up or down. But what do you think? It opens to the positive direction, right? But now the question is, should it be centered at the origin or somewhere down there? Or what do you know from x minus 7? 7 to the right. And isn't that what we call a 0 of the polynomial, right? So a 0, and that's the only 0, right? And it's an even 0. I hope that rings the bells, in our polynomial graph, right? So I believe that the graph looks like this. All right. So now, do you see that if you want any x values, right, that makes the entire thing positive, but do you see that the only number that's not going to work is the vertex, right? It's that 0, because that's the only number that makes the thing 0, right? So you'll be taking anything to the left of, the number is actually 7. So anything to the left of the 7, and anything to the right of 7, and that's what the B tells us. Okay. I hope that you don't have to go through that hard way, and you can, just write things through the logic. How would you make sure that x is going to take all real numbers except for the numbers that are not going to get you, a positive argument in a log. But 13 is the more intensive, one that you do have to do some math, right? So make sure you're getting it right. Now, we're requiring x squared minus 10x plus 16 greater than 0. And I believe that it might still be a good idea to graph, even that's just, a parabola, right? And indeed, it's because of parabola, it's easy to graph. If you remember that back in the polynomial graph, so we want to factor, right, the polynomial to see what the zeros are. I'm sure you can see it's x minus 2, x minus 8, right? So now, is it possible that you can describe what the graph looks like if the function is as simple as x minus 2 times x minus 8? It's still a parabola. Are there any zeros? 2 and an 8. And a parabola that opens, what's the leading coefficient? Is it positive or negative? Positive, so it has to be an upper open parabola. That's the only way you can draw it, right? But now I want the graph to stay above the horizontal axis, right? So let me highlight the part that you could look at. So it's going to be either to the right of the 8 or to the left of the 2, right? Only in those two intervals, the function value will be above, right, the horizontal axis. That's what you want. So it'll be from negative infinity to 2, right? Negative infinity 2 union 8 to positive infinity. Okay. Okay. Turns out there are two more ways, at least I can think of right away. So it's either plot that function f of x in number 13. Just type up exactly what you see. And I'm sure that you know back in college algebra, there is a way to read out the domain based on the graph. Right? Remember that? Just look for, if there will be any intervals that you're not supposed to take for x. So you play with the graph. Or you know what? We could type up that function and keep testing the points from those domains to see if you will see something that just not allowed, right? But that will take time, so that's why I just want to mention it. It's not definitely something you want to try, because I think that in this case, factoring it and do the graphing or whatever you do when it comes to solving polynomial inequalities, do that. It might be a safer bet. Okay. But I hope that when it comes to question from 11 to 14, except for 13, you might have to, be careful with it. But other than that, there are 3 remaining questions, 11, 12, and 14. They should be relatively easier. Yep. Now, I didn't plot the entire function in number 12. So I only plotted whatever that's inside the log. So this parabola, right, so this one only represents maybe, let's say, g of x. And g of x is x minus 7 squared, right? So now, the way you understand this graph is the function f of x in number 12 require the g of x to be positive, right? But do you see that pretty much all the points on the graph of g of x has a positive function value, except for this point. And this point has a 0 function value. And that's the only point you should exclude. And therefore, you ask yourself, what kind of value should you take for x? Feed it to the g of x, so then f of x doesn't complain. It will be all real numbers except for 7. And that other b is just like a strange way of skipping that number 7. Okay. All right. Now, from the question 21 to I think 35 on the packet for chapter 4, are all about condensing, expanding the expressions, involving logs. So like I said, the tools we have are the 5 properties on page 2 of the package for chapter 4. So the power rule, the quotient, the product rule, right, stuff like that. Now I hope that you realize there a general pattern behind questions that you have to expand a single log term into multiple terms like lengthy expressions, right? As you can see from those options in like 21, 29 to 30, right? Even 31. So now let me use a more general example so that you can tell right away what the patterns of the expansion should look like. So let's say you're looking at a function log sub b, right? The base b, whatever base you want. So you have a single term fraction that has maybe x to the power p times y to the power q over z to the power p, q, r, s, right? W times to the power of r, s. Okay. Now, how do you expand it, right? And using those properties, there'll be 4 terms. All of them are in terms of log of the same base. All right, so one term is going to be associated with the x, and its power p gets down, becomes the factor in front of that log. So it will be p times log b x. You have another term that looks like q times log b y. Right, so now those are the 2 terms coming from the x and y, right? Raising the power p and q on the numerator. For those 2 terms on the denominator, you have a negative since it's on the denominator. So you're going to subtract it from the first 2 terms with a power r brought down as the prefactor times log sub b, that's the log. Okay, and you put the z inside the log, and again, subtract the power s, again becoming a factor in front of the log, and log b w. Okay, so let me highlight just in the first term. So you see that the x stays inside the log, and its power come down, becoming the prefactor. Okay, and I need to emphasize. Oh, I think that's a bad idea. So I'm going to use a different color. So why are there 2 negative signs? They are the denominators, right? You have negative signs in front of the terms that came from the denominators. All right, so that should be the pattern you should be looking at. Now, well, I'm going to have the question 31 right on top of this pattern. Can you go through the options and find out which option must be right? Just look at the pattern. Good. Someone's down to C and D. Now this is only 50%. Well, more than 50% because you're not just going to guess, right? What's wrong with C or D? One of them has to be wrong. Yes. Letter C has a plus sign there. Oops. Right? Because this term that has x plus 4 came from the denominator, and it should have a negative sign in front, right? Therefore, it's letter D. Right? It's multiple choices. Right? You've learned it back and forth. I'm sure that you're taking the MAC 11.5, right, or 11.5C. I think most likely 11.5, right? So you've learned it. So now, how about one more try? Just to make sure that you are getting it. So I'll scroll up just a little bit. Try 30. Emmanuel, you said letter D, right? It is D. Right? It is D. Do you see how silly the option A and B are? They didn't even have to. They didn't even pull down the power. Right? You have to do that. All the power has to go in front. That means we're looking at C and D, and obviously that term has 1/3. Right? Log A x plus 5 has a plus sign because it's on the numerator. Not to mention the power is not supposed to be 3. You guys know why? Why it has to be 1/3? It's the cube root. So the root is the fractional power, right? It's not third power, but to the 1/3. Right? Cool. Guys, make sure that you try those easy ones, right? So you know that how things works out the same way as the complicated ones. But now condensing, some lengthy expressions to a compact term. So you're gonna do the same strategy. So I don't want to go back. You know that all the powers was supposed to go on top of, let's say in this case in 32, that power 7 should be back on top of x, right? That power 1/3 should be back on the top of y. And since that you're subtracting a term associated with y from, the first term, so this guy should go to the bottom, right? So some say C, right? So yeah, right? Power 7, now the power 1/3, right? Becoming the cube root, and this guy is supposed to be on the denominator since you have a negative sign, right? Now, what about 34? I'll go ahead and quickly try 34. That letter B. Yep. All right, let's see, in 34, you see a factor of 2, right? And it's going to go on top of the k. So that's why, there will be a k square. Now, in this case, do you see that they scrambled the order? A term that's associated with an n has a negative have a negative sign. That means that has to go to the bottom, right? So they have you no choice but to pick the letter B. Okay. Now, what do you have to solve equations? Now, I did have 3 pages in a packet for chapter 4, starting from page 5 to 7, with 3 methods. There was actually 4 methods, but one of them is a bit trivial, so I just skipped that. So the 3 methods plus a few examples I typed up. But at this moment, the test and final are multiple choices. So if you don't have too much time to review for all that method and get the algebra worked out correctly, so let's say, you know what? I'm always gonna pick 42 because that's probably the hardest one to do algebraically if you want to do it by hand. But I want to share with you, or hopefully you already know, how to use the calculator to test it. Okay. So now the reason why I said use the calculator, if that's an SAT question, solve for x, you have those options to choose from, what would you do in SAT? Yeah, you could do that, but it will be kind of complicated. You see how those options are complicated, right? So you can try the same base, but like I said, in SAT, what would you do if you have to solve an equation? Desmos, right? So now, what if you don't have Desmos, but you do have TID4? You can, no, you're not like that. So you can make it work, right? So let me make sure that if you haven't done it, maybe give it a try today to make sure that works out. Okay. But Desmos or the TID4, they are the best tool to use to graph a function. They could do equation, but it's not going to be the way that you like. So I want you to turn that equation, question 42 into a question asking for the zeros of a function f of x. Let me show you how I write that function. It will be 4x to the 4 x plus 4 to the x plus 4 minus 5 to the 2x plus 4. You guys see what I did? I subtracted the right-hand side, right? So that, don't you think that if I can find a zero of this function, however I can, the zeros are the solution to that equation, right? And you can graph this function to find the zeros, just like you would do, in a Desmos. So let's type up this function and see what it looks like. Oh yeah, thank you. That's 8.5. All right, so let's go to y equal, right? Clean that up. So I'm gonna do 4 to the x plus 4, right? So 4 raise the power to x plus 4, so x plus 4, right? So come down and subtract. Oof. 5 to the power 2x plus 5, 2x plus 5. Okay. Save it. So now you could even graph it and see what's going on. All right, so let me zoom in if I can do that, because sometimes TI-84 probably not going to do exactly what you want with just like you did with the Desmos. All right, well, it's hard to tell, okay? But it's okay, you have 4 options, right? What if I said, hey, test option A? How would you do that? If I were to plug this whole thing into the x, right, the function should return a 0, right? Let's see if it does that. So let's quit and let's recall the function by going to the variable, right? And the y variable, first option, hit it twice. So it's going to bring that y1, right? Let's feed it with the entire thing. Now, if most of you have the TI-84, I suggest that you play with that little functionality. If you can see it, it's that same button that I use for typing the x. But you have a green functionality. You have the numerator denominator, right? If you do that, it will organize your work in a better way. All right, so the way you do that is go to alpha and hit that button, so you get to putting, the numerator denominator. So I'm going to go with 5 ln 5. So 5 ln 5. So it asked me to put in the parentheses to close it. So let's just do that. Minus 4 log 4, 4 ln 4. All right, so minus 4 ln 4, close the parentheses. All right, so I'm done with the numerator. Go downstairs. So this is going to be ln 4 minus 2 ln 5, right? So ln 4, close the parentheses, minus 2 ln5, close the parentheses, right? Am I right? 5 ln5 minus 4 ln4, ln4 minus 2 ln5. Okay, let's go. All right, so close the parentheses and hit enter. All right, it is a 0. So now if you want to try to do it again, maybe somehow you're not that lucky, right? It's not going to work out. So let's say try letter C. So typing, y1, right? So it's going to put in 7 ln5, 7 ln5 minus 5 ln4, 5 ln4. All right, so make sure that you have the parentheses closed, right? You never know what's going to happen, but just be safe. Hit it. Oh, that's not a 0. Right. But the thing is, if you hit a 0 already, right, from one of the options, and obviously all the options are very different, I mean, there's no need to go through any other options. So now this is not going to be that efficient as Desmos if you haven't tried it. You try to do it in a test, but at least if you don't see it somehow from the basic algebra, for example, like for something as easy as 41, right? Not to mention 43. I mean, it should be very fast, right? If you just type up one equation, and just go ahead and test, a few options. That's all you have to do.